Good evening and namaste everyone. On behalf of Intas Pharmaceutical Limited, I Dr. Mithilesh Nayak once again welcome you all to this another unique webinar on storage in medicine. And to guide and moderate us, we are having with us Dr. Adip Mitra sir. He is a retired professor and head of medicine, LLRM Medical College, Meerut. He is a recipient of Lifetime Achievement Award from API Meerut branch and IMA Meerut branch, and is contributed as author for Textbook of Medicine Update 2015. So now I request Dr. Adip sir to come on digital podium. Welcome you, sir. Over to you, sir.
Hello. Am I on?
Yes.
Friends, it's a pleasure to welcome you all to this unusual webinar on the stories in medicine. It's indeed an honor to share the platform with luminaries of the stature of Professor Khaliullah and, of course, all the eminent speakers who are going to tell the stories today. Medicine is the youngest science. And although the father of medicine, Hippocrates, lived about 2,500 years ago, we are probably only 150 years old. When the first president of US, George Washington, fell ill in December 1799, he was treated by top 4 physicians of US. What they did was removed 2.5 liters of his blood. He was suffering from epiglottitis. Next morning, he passed away. So that is the story of the treatment given to the president of USA 200 years back. We would laugh at this treatment today. Another US president has fallen ill with COVID-19 and is being given monoclonal antibody combination. Probably our next generation will laugh at the treatment he has been given today. So with that small remark, I would start with the first talk. And our first speaker is Dr. S.P. Sondhi, who is going to tell us about the story of insulin. A brief introduction of Dr. Sondhi for people who are not known to him. He is a very eminent physician of this town of Meerut. He is currently a guest faculty in the Department of Medicine at Subharti Medical College. He is a course coordinator for last about 6 sessions for the certificate course in diabetes, which is run by the Public Health Foundation of India, along with Dr. V. Mohan. He was the organizing secretary of the RSSDI UPCon 2019, and what a success it was. He was also an investigator in the multi-center FDA-approved trial on tuberculosis, which was published in the New England Journal of Medicine. He has contributed numerous articles in various journals and books and updates in 2015 and 19, including Clinical Medicine Update 2015. And he received the Merit Ratna Award in 2003. So with that small introduction, I would hand over the session to Dr. Sondhi to tell us about the story of insulin.
Thank you very much, Dr. Mitra. And I am actually humbled to be speaking in the presence of stalwarts like Dr. Mitra. And I hope my screen is coming clear in front of you. Yeah, can you see my screen?
Yes, clear.
Thank you. So, ladies and gentlemen, it's a very exciting day for me. You know, this story of insulin is very close to my heart. Let me take you back to year 1918. 1918 was a very strange year. On one hand, Spanish pandemic flu was killing people. You know, almost like 20 to 100 million people died. And the scenes were almost like what we are seeing right now in Corona. But on the other hand, another a catastrophe which had already killed 90 lakh soldiers and 130 lakh civilians, World War I was ending. So it was kind of a very mixed year. And this World War actually brought out the two of the protagonists in our story, Dr. Banting on your right and Dr. Best on your left. Both had taken part in the war. And so let's follow what happened after the war. Well, as soon as the war finished, Dr. Frederick Banting was feeling relieved. He had taken a very active part in the war. He was actually picked up even before he finished his medical graduation. And so he had to join when Canada joined the forces with Britishers, and he went to the war. And he treated a lot of wounded soldiers there. He did amputations. He did a lot of surgeries there. He was actually awarded a military cross because of the valiant shown in the war. But at the end of it, he was sick of it. And he was feeling relieved that the war is ending. He was looking forward to going back to Canada to do two things, which were very close to his heart. He wanted to establish his practice in Canada. And two, he wanted to spend some quality time with his girlfriend, Edith, whom he had left in the war. Well, he went back to Canada and he failed to achieve both the objectives. For about 6 months or so, he tried to set up his practice. He invested in that, but there were no takers. He did not get clientele. So he got very disappointed. And on the other hand, his girlfriend also had moved on during the war. And so he actually failed to achieve any one of these objectives for which he had gone back to Canada. But, the war had taught him one lesson: to be very resilient, to be very tough, to take whatever comes in your way and to fight with it. So he joined the University of Ontario in Canada as a demonstrator. And he joined at the rate of $2 per hour. That's where he started working. And when he was working there, he was called upon to deliver a talk on pancreas. And in 13th October 1920, to be exact, Dr. Banting sat down to review the existing literature. He wanted to see what all is already known about the pancreas. And I will take you through his journey of that. He opened up his books. The books in those days used to be folded like this. And then he started looking at this handbook of medical textbook, which was published in 1920. I am able to take you through this book because I have this book with me. So this is where I opened in my house, and he started reading about the state of affairs at that time. And you'll be surprised to read that.
Dr. Sondhi, you need to stop for a while. There is some glitch. Give
Thank you. So I start all over again, and I take you back to the year 1918, which I said was a very strange year because on one hand, Spanish pandemic flu was causing a lot of damage. About 20 to 100 million people died in that Spanish pandemic flu. The scenes were almost like Corona in the present day. But at the same time, another catastrophe which had killed about 90 lakh soldiers and 130 lakh civilians, the World War I, was ending in that year. So it was a mixed year. And two of the heroes of our story, Dr. Banting and Best, both came out of this war. So let us take first Dr. Banting. Dr. Banting actually joined the war when he was in the final year of his graduation. And Canada joined British forces. and he went to the war, fought very gallantly as a medical practitioner. He saw wounded soldiers. He did amputations. He did surgery, and he did so well that he was given a cross as a service to the soldiers. But he was looking forward to ending this tenure because he wanted to go back to his country, Canada, for two things. Number one, he wanted to establish his clinical practice. And number two, to spend quality time with his girlfriend, Edith, whom he had left in Canada. But unfortunately, in the next 6 months or so, he failed to achieve both these objectives. He tried to establish his practice, invested money in that, but nobody, he could not create a clientele for himself. And his girlfriend, Edith, also had moved on. So he terribly, failed on both these accounts. But the war had taught him one thing, and that was to be resilient, to fight on. Even when the going is tough, one should fight on. And so he immediately changed his course, became a demonstrator in the University of Ontario at the rate of around, he was being paid $2 per hour. And once he was asked to deliver a talk on pancreas, and so he decided to actually see and review the existing literature about pancreas. This was exactly 13th October 1920. And I take you through that. He opened up a book like this, and this was a textbook of medicine published in 1920. I can do that for you because I have this book with me, and sometimes I open it up and see what was the existing state of knowledge about 100 years back. He also did that, and till that time it was clear that pancreas has two kinds of function. One, the whole of pancreas, which looked after the digestive function, and two, the islands, which are very small islands, which were concerned with glucose metabolism. So this was clear by that time. And by that time, actually, there was no treatment of type 1 diabetes. The type 1 diabetes, the main treatment was fasting, and more fasting. And this is the page from that book about the treatment. So most of the type 1 diabetic patients used to die within 3 to 4 years. If you look at the drugs available, well, this book says that opium is the drug of choice for treatment of diabetes. So look how far we have come in the last about 100 years or so. So this was the state of affairs at that time. When he went through that, he went through another article which says the relation of islet of Langerhans to the diabetes, with special reference to the cases of pancreatic lithiasis. And this article suggested that whenever there are obstruction to pancreatic duct, the pancreas becomes smaller, it shrinks, but beta cells don't die. So this article stimulated the mind of Dr. Benting, who thought, and he actually noted down the following lines in his notebook. He said, ligate the pancreatic duct of the dog, keep the dogs alive till acini degenerate, and leave the islets, and then try to take this islet secretions to treat glycosuria. So that was his plan. He got so excited that he started talking about this to everyone he meets. And everyone told him that if you want to do this work, the only place where you can do this work is with Dr. McLeod, who was the head of the department. He had a small lab and he had some dogs, etc., etc. And so one day he went there and tried to sell this idea. Dr. McLeod, when he met him for the first time, thought Dr. Benting was a very raw person. He never looked like a researcher to him. And so he tried to dissuade him. He tried to tell him, why don't you just scan the literature? Maybe there is some work already done on this topic, and so on and so forth. But Dr. Benting was so excited. He says, I don't want to waste my time in doing the research of the literature. I just want to do this experiment. So McLeod was anyway going out for vacation on this summer, and the lab was empty. So he said, okay, you can have the lab, you can have dogs, but I will not give you any money. So you do it on yourself. So ultimately, he was able to sell this idea, and he got 11 dogs, 1 intern, and this lab. This is the painting of his lab done by the Dr. Benting himself. And not many of us know that Dr. Benting was one of the best amateur painter of Canada during those times. So he got this lab, 11 dogs and an intern. For that intern job, 2 of the interns actually came forward. And, this is destiny. It was decided by the toss of a coin as to who will assist Dr. Banting first in the first few months. And on that day, the toss of the coin decided which one of them will actually go into the history of medicine and which will be relegated to the realms of darkness. Dr. Charles Best, at the age of 22, won the toss. And he was then to assist Dr. Banting in the next few months. And when this 2-3 months were over, Dr. Banting decided that he will continue with Dr. Best and not take the other intern. So this is what happens to you when destiny is on your side. So they actually started doing experiments, and they started operating on dogs. The first dog was accidentally killed by too much anesthesia. The second dog died from the loss of blood. The third died from infection. They used to operate on a wooden plank, which was difficult to be sterilized. And it was a hot summer in Canada, and there used to be beads of sweat rolling down their faces. And so it was very difficult to control the infection. And then, to cap it up, ligation of duct failed in about 5 dogs. The plan was to ligate the duct of dogs, let the pancreas shrink in the next few days, and then take the pancreas of that dog and then inject this pancreatic extract into the other dogs in which pancreas has been removed and they have been made diabetic. Why the ligation of duct failed? Because they did it with catgut and it opened up. Then they started doing it with silk and they succeeded. But in the first 7 weeks into the experiment, when they sat down to see the review of their work, there was just nothing to show but dead bodies of dogs. So many dogs have died, and they had not been able to do any kind of experiment on them. So much so that they had run out of their original 11 dogs. So they started buying dogs from their pocket money, as well as they started catching dogs which were stray dogs and bringing them to the operation table. Well, on July 11, Banting and Best depancreatized dog number 410. On July 18, they removed the pancreas of dog number 391. So the plan was that this 391 will be given pancreas of 410. How was the pancreas removed and made into a concoction? Well, pieces of pancreas was added with ringer lactate, was put into a chilled mortar and macerated with a chilled pestle, and then strained out, and a pinkish brown liquid came out. And on July 30th, 10:15 a.m., 4 ml of this mucky liquid was injected intramuscularly into the dog number 410. And the blood glucose came down by robustly 40% in this diabetic dog. Ileton was finally born. But unfortunately, the dog died the next day. Another dog, number 92, was kept alive without a pancreas with this Ileton for 20 days. And they continued these experiments in the next few months. In the subsequent months, they tried various ways to inject this into the dog's body. They gave it subcutaneously, they gave it intramuscularly, they gave it intravenously, they gave it into the rectum. They even gave it into the heart of a dog. So they tried all kinds of combination. And, it seemed that it was working. In the meantime, Dr. McLeod came back from the vacation and he looked at the experiment and the results, and he was encouraged. And he said, let's make Banting a regular fellow in our department. And so Banting was made a special assistant in pharmacology. And the pay was $250 per month. And he was also paid about $170 for his summer work. And finally, it was decided that they have an invention, and it was decided to present the paper in the Journal Club in Toronto on November 14, 1921, which happened to be Dr. Banting's 30th birthday. Well, the first human to have been given insulin injection on January 11, 1922 was Leonard Thompson. All of us have seen this slide umpteen number of times. On one side is the emaciated body of Leonard Thompson, and the other side is a robust, chubby cheek persona of Leonard Thompson after about 2 to 3 months of treatment. But not many of us know that when the first injection was given subcutaneous to Leonard Thompson, he almost died because of a severe reaction to the injection. The injection was impure. There was a lot of impurities in the injection. And so it was decided by MacLeod and Dr. Banting that let us call a biochemist into the equation now. And thus came Dr. Collip into this tale. Dr. Collip was a biochemist of repute at that time, and he was called to purify this extract, and he used alcohol to purify this extract. And he started making this extract and keeping this extract and trying to kind of monitor how much blood sugar does it bring it down. And so many of these experiments were later on done in rabbit. So ultimately, Dr. Collip, Dr. Banting, and Dr. Best actually patented the formula of iletin, which was actually insulin, and they patented. MacLeod was nowhere in the patent. And well, all the world knew that, there is some cure of diabetes which has been invented in Toronto. And this news was all around, and there was so much hope in the patients of type 1 diabetic that they all got very, very excited. And of course, there was injections being given to many of these in those days. Ultimately, in 1923, the Nobel Prize for Physiology/Medicine was given to Dr. MacLeod and Dr. Banting. Was Dr. Banting happy? Absolutely not. He was enraged to see the name of Dr. MacLeod in this Nobel Prize. And he was very upset that Dr. Best was not included in this. And so he openly said that I won't attend the function, and I will give half the cash prize to Best. Dr. MacLeod could not be left behind, and he says Collip was as important, so I'll give half of my cash to the Collip. Dr. Banting, even till today, is the youngest recipient of Nobel in physiology and medicine so far. Well, Dr. Banting and Best then sold the right of their discovery to Toronto University for just $1. They realized that it was a very, very important discovery. They realized the whole human being afflicted with type 1 and type 2 diabetes were waiting to get this. And so they did not want to commercialize it. And so they sold the patent for just $1. Later on, Eli Lilly company was asked to commercially produce it. And this is how they produce this iletin. And they also wrote down units, etc., etc. And subsequently, it came to be known as insulin. Well, ladies and gentlemen, I'm coming to nearly the end of the story. The Banting's initial idea was neither original nor successful. Actually, Banting, in one of his later interviews, said that if he had followed what Dr. MacLeod had told him in the beginning, that he should scan literature, he would never have undertaken this experiment, because there were innumerable citing in the literature that this has failed. But he did not look into that. He just persisted. His persistence led to a solution that was both original and successful. And in the end, ladies and gentlemen, Dr. Frederick Banting unfortunately died at a very young age of 49. But let me tell you that even after discovery of insulin, he did not stop medical research. Actually, he was doing research on a pilot suit, and he was going in a plane which crashed. And 2 people died on the day of the crash, and he died the next day. But he continued to work right till the end. Thank you very much, and I hope I finished my presentation in time.
Thank you, Dr. Sodhi. It was a wonderful presentation on the discovery of insulin. It It is acknowledging not only the brilliance of Dr. Benting, but also opening the eyes of all of us. Can I go on to the next presentation now? Before I do that, let me express my deep gratitude to Dr. Rajiv Agarwal for inviting me to chair this session along with very eminent physician, Dr. Udit Mitra. I'm very happy to be here with you all because whatever Rajiv does is usually unusual and unparalleled. When you see the seminar, no seminar in the country has talked about history of medicine. They are talking clinical subject, they are talking intervention, they are talking everything else, but not the history of medicine. So I think before we forget the history, he's reminding all of us as to what should be known and how it should be known. Wonderful heads up to you, Rajiv. Coming to Rajiv, I don't know how to introduce him.
Sir, let me interrupt you with all humility. I'll request Dr. Mithilesh to introduce my, permit me to say so, academic father. I always call him as academic father. There is a biological, and not me. Large number of people from GB Pant owe their life to him. I'll say we are fortunate, must have done something so that we got such a good teacher, mentor, and professor who shaped not only us, but cardiology in India. I'm sure, Dr. Those were very difficult days in cardiology. So I'll request Dr. Mithilesh to put a brief introduction to Dr. Khalilullah. I always call him teacher of teachers. So before I start, Dr. Mithilesh, kindly introduce Dr. Padma Bhushan, Dr. Khalilullah.
Thank you.
Yes, sir. Yeah. So Dr. Khalilullah, sir, does not need introduction, but as a customary, I am going to introduce, sir. Dr. Khalilullah, sir, is a living legend in the field of cardiology. He is a former director of GB Pant Hospital, New Delhi, and he made it as a Makkah of cardiology. And when we talk about the international scale, he is a teacher of teachers, as rightly said by Dr. Rajiv Agarwal, sir. And he did several firsts in the country to his name, from recording of potential balloon mitral valvectomy to Raskin umbrella device, and to form the first indigenous cardiac pacemaker in India. And he is a recipient of Padma Shri, Padma Bhushan, and Dr. B.C. Roy Award, and many more in the list. So with this, I welcome Dr. Khalilullah, sir, in the digital podium. Over to you, sir. Thank you very much.
Thank you. God bless you. Now coming to this next speaker, Dr. Rajiv Agarwal.
Yeah.
He has been one of my most brilliant students, having qualified from GB Pant Hospital. I've seen him during his tenure as a student, as a DM resident, as well as a post-DM resident. In fact, his metal was so strong that I was most taking as the faculty in the department. But the attraction to Meerut was so strong that Rajiv wanted to get back and help people in Meerut. And I'm sure he's doing extremely well, and he's helping a lot of people of all grades of society. And I think he is an asset to the city of Meerut and the people around. He's going to talk about prehistoric history of hypertension. It's very interesting, very interesting. I heard only a few sentences on this, but over to Rajiv. God bless you, Rajiv.
Thank you very much. It is always a pleasure to work under you and talking in your presence. I am privileged, and I'm going to talk something very, very interesting. How I got interested into it. My son has just finished MBBS. I'm talking a couple of years back, and I found him reading this book or other book. And one day I found him reading this book, and he didn't do well in pharmacology in medical college. So I was shouting, abusing like any other Indian father. You don't bloody read literature, and you keep reading these things. So he asked me, you pose yourself to be a big cardiologist. Can you tell me why the Afro-Americans are salt sensitive, diuretics work better in them, calcium channel work better in them, and renin-angiotensin system inhibitors, ACE inhibitors, they don't work on me. I was stumped. I had no answer. Then he asked me to read this book, and I'll say note down this book. This is a wonderful piece of reading, and each one of you will enjoy by a work done by Levitt and Dubner. And this is a real painting by Mr. John Carter, which is displayed in Brown Library at Brown University in Chicago. I am told that Raghuram Rajan was alumnus of this university. And this painting is very, very interesting. You can see large number of a tree sitting in ground, and there is a white man who is very, I'll say, finely dressed, looks from a bigger caste, bigger social stature, and he's licking this black slave. And that is what interested Levitt to dig out the story, that what is happening? How can a white man lick a black slave? And this is the foundation of this story. And the story started that these slaves were taken to America from Africa, what is called the Middle Passage slave route, and they were taken transatlantic. And you can imagine they were deprived of food, water, and everything. And many of them died on way to America. Slave, and he dies before reaching the destination. It is simple loss of money. It's bad business. They used to lick the saliva of these people, and if the salinity was high, if the sweat was more salty, that means they are excreting a lot of salt and they are unlikely to survive the transatlantic journey and they will die. So they are poor substrate for business. And if you are a poor salt excreter, that means your sweat is less saline, you are likely to survive the transatlantic journey, what we call the Middle Passage, and you will be sold in the market. So that means this is a man-made selection process of a genetic variation in Africa, which posed a different kind of challenge in times to come. This was 17th to 19th century, and people who were poor salt excreter, they were taken as slaves. And this is how you look at it. If you fall sick during the journey, you were thrown out of the ship. There are historical evidences which show that sharks used to follow the ships, and those thrown out of ship were the food for the sharks. So this was a very brutal era, and there is a famous movie which is called Ballet. Those who are interested in listening and understanding can go on Netflix and see this movie. It's a wonderful movie of 17th century. So that is how these slaves were chosen and sold to America, and that is one man-made genetic selection of poor salt excreter. And this is not just my imagination. This is an article published in Journal of American Heart Association Hypertension 91, and talked of the same concept, an evolutionary perspective on salt hypertension and human. Transatlantic Middle Passage may have created a genetic bottleneck for salt conservation in African Americans. And the severity of Middle Passage can account for comprehensively for the apparent susceptibility of this macro-ethnic group for high blood pressure and hypertension. And that is probably one of the explanations, not the only explanation, one of the explanations that why Afro-Americans are more prone for hypertension, which is salt sensitive because they are poor salt excreter. And this is the diagrammatic representation from the same article, which is called bottleneck effect or Grimm's hypothesis, selection of sodium retention during the Middle Passage in 16th to 19th century. Of course, with biodiversity over a period of time, there are many other factors, but philosophically, anthropologically speaking, this is one of the mechanisms which is often talked about. And I'll take this opportunity to dwell upon on sodium and ANP. This is a recent editorial which appeared in JAMA Cardiology by Dr. Thomas Wong, natriuretic peptide deficiency when there is too little of a good thing. And like hypothyroidism, they have talked about dilated cardiomyopathy as endocrinopathy, and the basic defect is atrial natriuretic peptide deficiency, which is documented in Africans. Probably these were the individuals who were taken in slave market as a good bargain. And if we look at the literature, this is Gupta et al. In 2015, 35 to 40% lower BNP level, 44% lower BNP level in MESA in regards, and probably that gene still plays a very, very important role in genesis of hypertension. And this is from the same editorial: obesity, male sex, black race, insulin resistance are important causes of natriuretic peptide deficiency, which cause high blood pressure, salt retention, diabetes, and left ventricular hypertrophy. Obesity, when it becomes inflamed, what we call as adiposopathy, degenerate, disintegrate, and proteolyze this ANP. So same level of stress in myocardium, you have less of ANP in obese patient, up to 50%, and these patients, they start retaining salt. And that is one of the reasons why some people who have obesity are associated with left ventricular hypertrophy without hypertension, and salt retention manifesting as edema, for which you don't find any other cause. If you look at the drugs, ARNIs, they decrease ANP degradation and increase ANP levels. DPP-4 reduce proteolysis. GLP-1 receptor analog increase secretion. Phosphodiesterase inhibitor work through different mechanisms. Cyclic GMP, second messenger for ANP and BNP release. Diet, exercise, and bariatric surgery may also increase ANP twofold. So looking at it, that we are exploiting this mechanism, and what I have told you is probably one of the man-made genetic selection. Look at the sodium levels in the blood. It has got a U-shaped curve. You have to be in between. If you have low levels of sodium, then probably you have higher mortality. If you have high levels, then you have higher mortality. Hypo and hypernatremia and congestive heart failure at the time of admission is bad outcome indicator, which at one point suggests hemoconcentration here is hemodilatation. What happens? When you have low sodium, the renin-angiotensin system, it increases. And I'll come back to my story since my patients, since the slaves who were exported to America had more intravascular sodium, they were poor salt excreta, so plasma renin activity system was less activated in this patient population. And what does it mean? You, in Afro-Americans, you have less of coronary events, more of renal failure, more of a stroke, more of left ventricular hypertrophy, more of hypertension, but less of coronary events because the renin-angiotensin system is less activated because of high salt content in the blood. So that is another extension of the hypothesis we have generated. We know that the plasma renin activity is low in African origin because they retain so. And if you look at reflection of high sodium and low level of renin in blacks. This is Dr. Arthur C. Guyton. Each one of us know that kidney is involved in the genesis of any type of hypertension. All forms of hypertension are ultimately the consequence of resetting of the pressure-nutrition relationship. This is I have borrowed from my nephrology colleague in diabetic kidney. As there is loss of nephron, the curve shift to the left, to the right, and you start retaining more and more of sodium. So kidney is the culprit, even in the absence of disease, kidney disease. And they say very famously that 80% of the patient who are 80 years are hypertensive. The only safeguard against hypertension is to die early, because each one of us have to become hypertension later in life. This is the sodium recommendations. At the sodium intake increases, the mortality increases. Dr. Khalilullah is my teacher, mentor. He asked me, Rajiv, tell me what are the salt consumption in Indians? So I had to work hard because I know he's going to ask this question. The normal recommendation is 5 grams, and we roughly consume about 9.45 to 10 grams of salt, almost double. Government of India is creating a program. I do not know where is the program, but on documents, they intend to reduce the salt content by 30% by 2025. This is, if salt content is reduced in diet, BP reduction is more in hypertensive. If you substitute it with potassium, you do still better. So sodium intake and reduction by food formulation in the European Union, that is how they reduce 5% per weekly, and then sodium chloride by potassium chloride up to 10%. That is the plan, how the community can be helped by reducing salt. Salt intake in India, it is a very alarming situation, and we come to a zone where we have very high 300 to 400 people per million dying because of excess salt intake. And that is how I'll say from historical to modern perspective, the shift is that we have to consume less salt and advise our patient to have less salt. The intake prevention in cardiovascular diseases, that is how the community behaves. There is a very famous study which is done in Portugal, consume huge quantity of salt. They have reduced by 25%. The community blood pressure has gone down by 5. Linear relationship in fall in stroke and ischemic heart disease. Salt substitution by potassium is another very important intervention. This is how you reduce the number of deaths. This is how you reduce the number of deaths by adding potassium. There is slight increase in death because of manifested renal dysfunction and hyperkalemia, but net averted deaths per year are huge. But this philosophy doesn't work in kidney disease. So, ladies and gentlemen, I have tried to present you a very funny story of man-made genetic selection in slave markets and how it transformed our understanding of salt-sensitive hypertension, why the black salt reduction, because they are poor salt Thalidomide drugs are more effective, why ACE inhibitors are less effective, why calcium channels are more effective, why there is less of atherosclerosis in blacks vis-a-vis in whites, why there are more stroke. So I have tried to open up the Pandora of several puzzles and given you one of the possible explanation. I'm sure you would have enjoyed it. And this is how we have to use our corona times, and we have to repair our net so that we present ourselves to the community in a better way. And let me say, these days, since webinar is the day of the order of the day is like breath every day, I'm sure this webinar will enlighten you. It will not be yet another webinar. Thank you very much. And, sir, you are muted. Sir, you are muted. Dr. Khalilullah, Dr. Adib Pitra, both are muted.
Thank you, Dr. Rajiv, for that very illuminating and excellent talk, a new perspective on hypertension. Speaking of salt alone, I have read the book you mentioned about Stephen Levitt and Dubner. They are a journalist and economist combination, and they have written 2 other books called Freakonomics and Super Freakonomics, and I recommend everyone to read those books. They are very good read. You mentioned about Dr. Guyton. I would say one more thing about him, that he had 8 sons and all 8 of them became doctors. That is another story about Dr. Guyton, whom we have all read. Dr. Sondhi also gave a very illuminating talk, and I wonder, Nobel Prize is given to a maximum of 3 people in a subject. So I wonder why best was not given, because they don't give more than 3 people, but 3 is the limit. And of course, it is not given posthumously. So we now move on to the next talk. It is a pleasure to introduce Dr. Rahul Bhargav, who is a familiar figure in Meerut. He's a director and head of hematology, Fortis Hospital, Gurgaon. He started his journey of stem cell transplantation from Medanta in the year 2010, and he has completed 800 transplants, which is a very impressive number, I must say. With a vision of anemia-free and thalassemia-free India, Dr. Rahul Bhargav actively collaborates with various government initiatives in order to provide low-cost BMT treatment to the masses. In 2016, Dr. Bhargav became the first Indian doctor to do and popularize stem cell transplant in multiple sclerosis. Owing to his vast experience in this field, Dr. Bhargav is considered as one of the best stem cell transplant experts in Delhi and Gurgaon. Dr. Bhargav is actively involved with the community in building awareness around various blood disorders. So it is a pleasure to hear Dr. Bhargav, who is an expert in this field. Dr. Bhargav, please, he'll be talking on history of sickle cell disease in relation to malaria.
Thank you, Dr. Mitra. Thank you, Dr. Agarwal, for giving me this opportunity. I mean, by now I have attained the citizenship of Meerut, and every single physician has bestowed their blessing onto me for serving the population, rural population, as far as 150 itself, about the various disease manifestations and how they present to us. So history of sickle cell disease is a very interesting topic. But though the sickle cell in terms of malaria is a one paragraph thing, that nitric oxide causes cerebral malaria people, similarly of carbon monoxide, and that's why those have got a survival advantage, and that's how people survived. So it's a natural selection. Before that, but interestingly, a disease which has been affecting the African continent for so long goes 110 years back. Next slide, please. So apparently, every great thing which tends to come has been discovered by astute physicians sitting in America, because they could have a larger vision of understanding what is happening. So, say biconcave cell, we have a sickle kind of a cell which is seen under the microscope, and how it started. And thanks to cardiologist Dr. Agarwal, cell into the real world, and after that is a history, because Americans have been pumping quite an amount of money in this moment of time on sickle cell and its prevention, and African American community they have mixed up into America. Next. Next. Okay, so what is happening in sickle cell is the red blood cells are rigid and sticky, and they're shaped like sickles or crescent forms. They tend to stick into the smaller blood vessels, leading to the crisis which they are part of the body. So how they have a myocardial infarction, or they have a painful crisis, or they get stuck into lung vasculature, leading to chest infections, leading to similar pain crisis. And one of the three most affected countries are in Nigeria. Probably not many people are aware of sickle cell, but as you go towards Nagpur, Chhattisgarh, Jharkhand, people do get suffered with sickle cell, and the predominant problem is of the pain. So the fact is, those sickle cells are in such a manner, the hemoglobin curvature, because of the protein defect, that it cannot navigate the capillaries and the smaller veins. Next slide, please. So definition we all know is an abnormality of hemoglobin molecule. So remember this word called molecule is very, very important, and the molecular defect. So for the first time in many times in 1900s, the sickle cell was attributed to the protein molecular deficiency into the system. So for the first time, it was discovered that because of some molecular defects, people can have these kind of a problem. Next. Next slide, please. So here's my slide, please be attentive because I tend to go very fast. So in 1904, Walter Clement Noble traveled from Grenada in the United States studying at Chicago College for Dental Surgery. A few months later, he was admitted to Presbyterian Hospital in New York, Chicago, where he developed severe respiratory distress and a leg ulcer, both of which were symptoms of sickle cell, which was unknown. Then what happens, Dr. Ernest Irons, the intern who was on duty that day, performed a routine blood test and a urine analysis for Noble and was first to observe these pear-shaped elongated sickle blood cells. So what was happening? He was interning under I would say he was interning under a cardiologist who was not interested in seeing these people, that what is happening. So report on Walter Clement Noble dated 31st December 1904. For the first time, this abnormally looking cells were seen under the microscope. Next. So these guys, because these American communities has got a huge African population and they tend to present to you with pains and so on and so forth. So this guy tends to go to the emergencies more often than not. And then astuteness of a cardiologist and the intern who was this guy was interning, he thought over why these guys keeps on coming to the emergency department for frequent infections and frequent leg pains. And this is how it turned out to be, that he saw these elongated cells. By that time, nobody knew it about what those elongated cells looked like. Next slide. So it was not until 1910 that James Herrick, the supervisor of Dr. Irons, and James Herrick was basically a cardiologist, or at that time could be a internal medicine guy, published his article describing these peculiar elongated sickle-shaped red cells, corpuscle in a case of severe anemia. This was the first documented and recorded case of sickle cell in Western medicine. So though it was the intern who discovered it, but the supervisor was a James Herrick who turned out to produce the first paper. So Dr. Noble returned to Grenada in 1907 and ran his dental practice in St. George's, the capital city. So that guy who went in 1904 go on to become the first person who was diagnosed with who was first diagnosed with sickle cell disease. Next. In 1917, the genetic basis for sickle cell disease was enumerated by Dr. V. Emanuel. The third case of sickle cell was described in 1915 by Cook and Meyer in 21-year-old female. Interestingly, blood samples from both the patient and the father who displayed no symptoms. So they were elongated cells, and that was a serendipity, because in sickle cell trade, there is generally no sickle cell roaming. But in this case, there was a sickle cell, but there was no symptoms. And that's how they could see that it was in a heterozygous state and not an homozygous state. So this observation made by Dr. Emanuel suggested a genetic basis of the disease, but also led to a period of confusion with the genetics of the disease, because at that time, it was not thought over the genetics can cause the major problems. Next. So in 1922, we mentioned names the disease as sickle cell anemia. Dr. Manson, who observed the fourth reported case of sickle cell, was also the first to call the disease as sickle cell anemia, because those cells were predominantly leading to anemia. He also noted that these patients were black, inadvertently given rise to the popular misconception that sickle cell originated from people of African origin. So it was a conglomeration of these African black people whom these people were experimenting with and seeing their blood samples, and they were found to be thinking that these are basically from Africa, African originated from Nigeria, and because of the selective pressure on the trade, they could survive the malaria endemic in those regions. Next. So this is where the erythrocytes comes in and leads to all these problems in hemoglobin, oxygen, and so on and so forth. And this is how hemoglobin and the red cells were discovered, how the protein interacts with the genetic deficiencies were elucidated. Next. Next slide. So this is the inheritance of a sickle cell disease. Next. This is all we know. Next. Next slide. Next. So mystery has been solved in 2011, paper published in Cell, which talks about the carbon monoxide being protected the infected host from the to cerebral malaria without interfering with the life cycles of the parasite inside the cells. So what happened is, in 1900, from that, the 1950 defects are because of the deficiencies in the protein, and interaction was well illustrated in 1951. Following which, what happened was that the hypothesis started coming back that how the sickle cell trait confers the protection with malaria, and then probably in the last 10,000 years, people would have survived the endemic region of in the endemic region in Nigeria, which is infested with malaria. So this is how a brief history of sickle cell, the astuteness of a person, understanding and asking questions which are relevant to the human mankind, that why this is happening leads to the problem solving for one of these major diseases. And as you'll be surprised, the government of America, this last month was a sickle cell awareness. Even President Trump spoke about sickle cell in their Senate debate. So you see how Americans are pumping money into their 210 plus trials which are going on sickle cell to finding out the cure for that. Still now, the only cure is bone marrow transplant. Gene therapy has gone a long way. If you see, in last 10 years, genetic therapy, CRISPR technology has helped us to understand and insert the relevant gene into the genome and leading to the protein synthesis in this manner. So gene therapy has become very, very successful. Thereafter, glutamine, a simple glutamine, which gets into the cycle of preventing the sicklers to prevent the sickle cell getting stick to the vessels, have become more elucidated. And the lectins and other molecules on the red cell surface has become more relevant in today's manner, because we can target these with medications leading to less of painful crisis. So see, in last 20 years since American has waged a war against sickle cell, they have been able to come up with new molecules, giving a hope for these people to live longer. Thank you.
Dr. V.S. Narayan, he is a star cardiologist of Lucknow.
Yes.
I think I know him for the last almost 30 years, maybe even.
Yes, that's right. More than that, sir.
I've seen the Department of Cardiology in Nari Medical Center, and now the Department of Cardiology of King George's Medical University from the inception, from then onwards. And Dr. Mansoor Hassan, their professor and head, was a very dear friend. I used to go from here to Lucknow quite frequently. Dr. Narayan is a very accomplished cardiologist. He has excelled over a period of time. He is a very good teacher, excellent examiner, and also has contributed a lot to the research in the field of cardiology. I'm sure he's an asset to Lucknow, and under him, the Department of Cardiology is now almost second place in the whole country in terms of stuff.
Second is Pant.
Second spot in the whole country.
Number one is Pant, and number two. Sir.
Yes, so I've seen the department growing from step to step, and all this is because of the leadership and dedication of P.S. Narayan. I'm happy to introduce him for the next topic, and yes,
there is something going on in the background.
Right, some background.
Somebody is speaking in the background.
Amit, there is a lot of background.
Possibly the most prescribed molecule in the whole world. That is statins. The physicians write, the cardiologists write, the cardiosurgeons write, and even some gynecologists write this, And therefore, the history of statin is a very interesting one. And I request Dr. Narayan to please proceed with the presentation. Dr. Narayan, please.
Thank you, sir. Thank you, Dr. Falla, for those kind words. And I thank you, Rajiv, for giving me this opportunity to speak on statins. And thank you very much for recommending that book, The Loon Shots by Bakal. This is a book which I bought and I've read quite a lot from it. And it's a lecture which we are proposing this evening also comes largely from that book. So I, as a child and even now, love stories which have a lot of pictures. And that is what I have done in this lecture also. Am I audible? Can everybody hear me? Yeah, okay. So the story of statins is basically a story of two continents, Japan and the US, two pharmaceutical companies, Merck and Sankyo, three men, Akira Endo, the father of statins, and the Brown-Goldstein combination, which did so much work on cholesterol. And then it is mainly about Akira Endo and his fascination with the blue-green mold. Now we know that most ideas will not go smoothly up to being sold as drugs. It is never a happy journey upwards from idea to cure, and there are many ups and downs in the discoveries before you finally make it. Your idea may be ridiculed, your experiments might fail, your budgets can be cut, and you could be even fired for no reason. And you can be really life can be made very difficult, when researchers could be denied tenure and the results would not be published. Executives would not allow them, be really stubborn of allowing you to move forward with your project. But bright ideas should be nurtured and protected. That's what the father of statins, Akira Endo, did. He did not assume that his bright idea would blast through the world barriers by the power of his brilliance, but persisted with devotion and nurtured an idea, and finally we've got what we have today. So James Black was a Nobel Prize winner 1988 for a modern approach to drug discovery, said that a good drug is never a good drug unless it has been killed 3 times. And that is also about statins, a story of 3 deaths, as they call it. But let us go back to look at the history of heart disease to begin with. It was in 1768 that William Heberden first described angina pectoris, and the only treatment that he could offer at that time was liquor, opium, and rest. It was not until 1945, when Roosevelt died of a brain hemorrhage, it was realized that it is not a bolt from the blue, but that he had chronic hypertension and chronic heart disease. And it was realized that heart disease is not an inevitable result of aging, but a disease in itself. And his death triggered research into heart disease. In 1948, we had the National Heart Institute set up. And this institute funded the largest population study, the Framingham Heart Study, which gave us the concept of risk factors. And it was the first study to show that high blood cholesterol conferred a high risk for heart attacks and strokes. And therefore, we had a surge in clinical studies looking at diet and drugs to reduce cholesterol in an attempt to reduce heart attacks and strokes. And for the work on cholesterol in 1964, Conrad Bloch and Leinen got the Nobel Prize in the research. Now let us shift to Japan, where we have Akira Endo, the father of statins, and let us hear the story of his tryst with fungi, molds, and mushrooms. Akira was born in Japan, and he was inspired by Sir Alexander Fleming and his isolation of penicillin from the blue-green mold, and also by Waxman, who isolated streptomycin from Streptomyces gracilis. He joined the Tokyo University, and after graduating, he joined the pharmaceutical company. But as a child, when he walked the forest with his grandfather, he observed that there were certain mushrooms which were toxic to flies. And in his college experiment also, he had made some broth. He found that this broth made of mushrooms was toxic to the flies. And therefore he inferred that fungi were great chemists. And they were producing chemicals which could discourage predators. Molds, he realized, were secreting chemicals to make their host juicier and more. So he realized that fungi are great chemists. And with this background, when he passed out, he joined the Sankyo company, the pharmaceutical company, and he isolated a pectinase from the fungus. And this pectinase hydrolyzed pectin, which contaminated whites and ciders. Now, this was commercially useful to Sankyo, this pectinase which he discovered. And for this, Akira Endo was given a paid sabbatical to study in the USA. Now, he was interested in cholesterol research by that time. He joined the Einstein College of Medicine, and he worked on the role of phospholipids in the synthesis of bacterial cell wall for the next 2 years. Now, at the time when Endo came to the US, coronary artery disease and deaths from heart disease were peaking. And the idea was developing that diet was the cause of heart disease. And this was published by Ansel Keys in his famous 7-country study, where he said that elevated cholesterol caused heart disease and that diet, especially rich in saturated fat, was the cause of it all. And the legacy which Ansel Keys left was that bad diets cause obesity, and therefore he suggested that you should have a diet low in fats and high in carbohydrates. Now we know that this is not actually correct, that high carbohydrate diet is not actually good and fats need to be taken in some measure. However, Ansel also studied that Japanese who were coming to Hawaii from Japan and who were consuming Western diets had high levels of cholesterol and a higher incidence of heart disease. And that was Endo's observation also. He found that in his neighborhood, fat people were getting picked up for heart attacks. And he latched onto this idea, this connection between obesity, diet, cholesterol, and heart attacks. It was his fear that Japan was getting westernized very rapidly, and that this westernization could lead to high levels of cholesterol and an increase in the incidence of heart disease. Therefore, he decided that he must find a drug that could take care of this impending epidemic of heart disease, and he must find a drug that could lower cholesterol. So he came back home with this idea and returned to his fungi because he already knew that fungi had some or great medicinal value. They produced some chemicals which were, detrimental to bacteria. Bacteria being natural predators of molds, and since molds and mushrooms could not run, they evolved methods to kill them. So what were the methods these fungi were developing to kill bacteria? That was the focus of his study. And the way was shown by Alexander Fleming, because he had shown that Penicillium notatum, a fungus, was secreting a compound that caused a collapse of the bacterial cell wall. So the fungi were producing something that was causing the collapse of the bacterial cell wall, and that was the mechanism of action of penicillin. Now, in the USA, Endo had learned that bacteria, in order to survive, needed cholesterol. And therefore, he got this idea that fungi could be secreting something which was blocking cholesterol production. So that was his idea on which he decided to work, and he speculated that fungi may be producing an enzyme that was inhibiting HMG-CoA reductase, something which was preventing cholesterol production in the cell wall of the bacteria, causing the cell wall of the bacteria to collapse and thereby being sort of useful against them. And that was the basis of his search. He began looking for a specific compound from these fungi that could surgically block cholesterol. And he developed a method. And with that method, he began screening fungi, tested more than 6,000 species of fungi. In 71, he chanced upon citrin, which strongly inhibited HMG-CoA, but this citrin was very toxic to the kidneys. So he moved on for another year, and in summer of 1972, he hit upon the blue-green mold, which was growing in rice in a grain store. And he isolated the most active compound from this fungus called the ML236, and he called it compactin. Later, it was called mevestatin. So compactin and mevestatin will be interchangeably used from now. And this mevestatin was structurally similar to HMG-CoA. It acted as a competitive inhibitor. And mevestatin was the seed from where all the statins have sprung. For his research, Endo was given the 2008 Lasker Debicki Prize, and he is the one who has saved millions of lives since. But coming back to how the statins survived the 3 deaths. Back to the USA, at a time when Endo was doing his research, trials were going on to study the effect of cholesterol lowering, especially with diets and with drugs, and they were mostly failing. They were found less efficacious. There were a lot of side effects, and the belief had emerged that cholesterol, being an essential component of cell wall, was essential for the survival, and therefore if you try to inhibit cholesterol synthesis, you will be causing toxicity. And then you had this editorial in 1977 in the NEGM, said diet heart, end of an era, said the generation of research has ended in disarray. The British Medical Journal said that all the controlled trials have failed, and the evidence adds up to little more than 0. And said cholesterol research is nothing but a fundraiser for the Heart Association and busy work for thousands of fat chemists. So that was the situation, and cholesterol connection was, ready to be buried. All the academic interest was lost. Companies decided not to pursue any research. And it was in these times that poor old Endo presented his paper to an empty hall. Nobody came to listen to his talk. That was the first death. Now he came home very disappointed. He wanted to continue his work and he was expecting to be fired, but fortunately there was some reputation behind him which did not get him fired. And so he started testing mevestatin in rats. But there was no effect of mevestatin on rats, so that was death number 2. Now Sankey was not ready to allow him to carry on any further study, but Endo pleaded, let me look at the factors which are not allowing this drug to work in rats. And he chanced upon his friend who was working with chickens. And since he thought that eggs had a lot of cholesterol, chickens might be having a lot of cholesterol, and that perhaps mevestatin could work here. And it did. It caused a dramatic reduction of cholesterol in chickens. So the reason was that chickens, even monkeys and dogs, have more LDL, and they're closer to humans, vis-a-vis rats who had more of HDL and less of LDL, and that was the reason the mevestatin did not work here. Failed by rats but saved by chickens, Sankey launched the development project on mevestatin in 1976. Now, coming back to the USA at that time, where I have said that cholesterol was more or less dead in the USA. So enter Brown Goldstein, and they dug up cholesterol once again from the grave. And they pushed back the pessimism on cholesterol, and working on a 6-year-old boy and 8-year-old sister who was suffering from repeated heart attacks, they chanced upon the discovery of familial hypercholesterolemia in 1977. They published so many papers together, and they even got the Nobel Prize for their research in 1985. But going back to 1976, when they were looking at treatments for their familial hypercholesterolemia, they chanced upon the works of Endo. They contacted Endo, asked him for the drug. He gave it, and they found that the results were fantastic in familial hypercholesterolemia. They encouraged Endo to use it in his patients. And so Endo got in touch with Rabamoto, and he used it for the first time in a Japanese girl whose name would be henceforth known only as SS. And that's a picture with a child. She had a dramatic 30% drop in her cholesterol with the use of this drug. Endo was very happy. He retired from Sankyo, joined the university. Other companies started searching for statins. Merck was first out of the gate. He had some contact with Sankyo and with Endo, and with the information that was available, they found in 1977 meverilin from the fungus Aspergillus terreus, and this was called meverilin was called lovastatin by Merck. So this was the first statin which Merck discovered. Sankyo launched this program, but little did Merck and Sankyo know that the third death was around the corner. 3 months after the Italy meeting, mevastatin was knocked out by a safety study which found that high doses of mevastatin was causing lymphoma-like lesions in rats. So Sankyo was fed up, shelved the program, and since this news traveled to the US, Merck also suspended this program. And so this was death number 3. The statin project lay in fallow for 3 years, but all this while, both Endo and Goldstein knew that there was some problem with the tumor trial, and that this trial was flawed. So they persisted. And they persisted with Merck also. And fortunately for Merck, Edward Shalding entered the leadership role at Merck. He relooked at the tumors and found that the tumors which were known to be developing with mevastatin were actually not cancer, but simple histological changes due to a subcellular processing of very high doses of drug, more than 20 times the dose which you give in humans. So this was not tumor. So Merck restarted the program in 1984 in dogs, found that it was working very well as far as cholesterol reduction is concerned, and there were no tumors. And these safety reports stimulated many clinicians to try this drug in individuals with high cholesterol, where found that this is dramatically reducing cholesterol and causing little side effects. They persuaded the FDA to test it in humans, and in February 1987, FDA approved the first statin from Merck, Mevacor or lovastatin. Ever since, we have so many statins, 2 semi-synthetics and 4 synthetics, and the outcome studies which came next have proven that statins reduce heart attacks, strokes, and prolong life, and they have been hailed as one of the greatest medical breakthroughs of the 20th century. Few drugs have had such a dramatic effect on health outcomes. Merck made millions. Vagelos was promoted to CEO in 1985. Goldstein and Brown won the Nobel Prize in the same year jointly. But Akira Endo's work was largely recognized only by his friends. Goldstein and Brown said Akira was the discoverer of the penicillin of cholesterol. And he said in a review, the millions of people whose lives will be extended through statin therapy owe it all to Akira Endo and his research through fungal extracts of the Sanyoku. Endo did receive a lot of prizes for his work, but the Nobel Prize was not his to take. In 2017, he was given the Canada Guardian International Award for the first discovery and the development of statins. Akira Endo's story from start to validation by the FDA lasted 16 years. It was a long, long story. The story of statin is more than a wild anecdote. It says that the twisted path to discovery is a rule rather than an exception. 16 long years of research, failure, success, research, success again, failure again. A long twisted path to discovery. Much before Akira had found the statins, at a 1964 Nobel Prize dinner, it was said, it was speculated, it was hoped that we may look forward to a time when mankind will not only live under vastly improved conditions, but will itself be better. Life will be better. Life will be longer and better. This was what was hoped for in 1964. And Goldstein Brown in 1985 said, it may be one day possible to have many people to have their stakes and live to enjoy it too. With statins, I think we are well on the way to this time's a happy, long life. And we owe it all to this guy, this Japanese who persisted with his passion, Akira Endo. And so said Isaac Newton, no great discovery was ever made without a bold press. So let us all thank Akira, Brown Goldstein, and all his mates for giving us statins and giving us hope for a long and useful life. Thank you very much.
Thank you, Dr. Narayan, for a brilliant presentation of the origin and discovery of statins for a period of time. And today it is the compound very widely written the world over. And the only thing is that its role in people above the age of 65, 75, and 85 years of age is still doubtful. Now, I'm getting about 85, so I don't know whether I should take statin or I should not take statin. My daughter, son-in-law say they take statins, take aspirin. I said, no, I don't want to take that. Now, these are all controversial areas where you need to clarify, because people at large, especially practitioners, keep writing the drug indiscriminately. So they have to realize that. And number two, I talked to a company at one time that the amount of statins written in the clinical prescription today is equivalent to half the GDP of the government of India. So if you extrapolate the findings of what is happening in America and other European countries to India, economically it is feasible or not, I do not know. But to save 4 people, you treat 996, whether justified or not, I don't know. So these are things which had to be understood and clarified. But your history of statin is brilliant, and how an unknown experiment can prove to be an eyeliner and can create history in mankind. Thank you very much, and God bless you, Dr. V.S. Narayan.
Thank you, Dr. Narayan, for your very scintillating talk. You mentioned Dr. James Black, and he is credited for 2 other very important inventions. One is beta blockers, and the other is H2 receptor blockers. So I think he is another person who is one of the history makers of our times. So finally, we move on to the last talk by Dr. Sanjay Agarwal. And it's a pleasure to introduce him. He's the director of the Eagle Clinic Diabetes Care and head of the Department of Medicine of the Ruby Clinic Hall in Pune. He's a senior consultant in diabetes and medicine, Jahangir Hospital, and fellow of the American College of Endocrinology. He's honorary secretary to the governing council of the National RSSDI and is a member of the editorial board of BMJ. He's author of a book, Clinical Atlas in Diabetes, and has contributed chapters in various books. He's a faculty at various national and international meetings. So over to you, Dr. Agarwal, for your talk.
Thank you.
On the SGLT2 inhibitors.
Thank you very much, and I appreciate and feel humble with your introduction. Can I just share my screen? Are my slides visible to you?
Yes.
Yeah, thank you. I think it was wonderful to hear all the historical reviews of the previous speakers. It really it's mind-boggling the way medicine has progressed over a period of time. Never ever has a molecule evoked so much interest as the SGLT2 inhibitors. It's like a work in progress, and there is very little historical review that I can give about the SGLT2 inhibitors. But what started out as a drug for the diabetologist has now become a primary drug for the cardiologists and the nephrologists. And why has this really been so? And rightly so, because there's been so much of data over a period of time that has come forth, which has shown that this drug is probably the choice when it comes to dealing with heart-related problems, where diabetes is concerned, as well as nephrology, all the kidney-related problems. So let me just trace back a little history. And these were the fathers of SGLT2 inhibitors, Professor von Mering as well as Koenig. And if you see the timelines, they started out in 1835, and they isolated fluorescein from the bark of the apple tree. In 1813, somewhere around in 1933, fluorescein was shown to completely block the renal glucose absorption in humans. And in 1938, the renal glucose kinetics were characterized, clearly demonstrating maximum reabsorptive capacity and threshold for glucose excretion. In 1960, the active co-transport concept was proposed for intestinal glucose absorption. And in 87, the SGLT1 was cloned. The fluorescein treatment was shown to reverse glucotoxicity in diabetic rodents. In 1992, the SGLT2 was cloned. And in 1995, the first report of treatment of potential of a selective SGLT2 inhibitor was published. Over a period of 2012 to 2014, the first SGLT2 inhibitors were approved for treatment for type 2 diabetes. So clearly, 130 years after von Mering's original discovery, the first clinical trial based upon this mechanism was published, with very little history that's happened in the last 130 years before the trial was published. So I'm really going to take you through as to why SGLT2 inhibitors have really become so popular. And when I talk about stories, it's not just historical review, but the story also means that how has a particular drug changed lives and improved lives for the better? And that's what a story is. So the earliest description comes with the use of fluorescein and how it really works in blocking off the renal glucose excretion. Generally, we have a filtered glucose load of about 180 grams a day. And if you don't give fluorescein, the glucose excretion is less than 0.5 grams per day. If you block the receptors with fluorescein, more or less, practically most of the glucose is excreted. Similarly, if you look at the renal absorptive capacity, as we know that most of the glucose excreted through the glomerulus is reabsorbed back from the tubule. Now, if you block the receptors, less than 1 gram of glucose is reabsorbed. We are familiar with the architecture of the nephron, and we've got the S1, S2, and S3 tubules. Most of the SGLT2 receptors are located in the S1, S2, and the SGLT1 receptor is located in S3. And if you look at through micropipettes that they have shown, that majority of the glucose absorption tends to occur in the S1, S2 tubule, and very little goes through to the S3 tubule for a reabsorption. This has been the landmark studies which have shown that how does really the co-transport happen. Remember that God really gave you the kidney, and the whole primary purpose of the kidney was to maintain the intravascular volume. And the key factor that was responsible was sodium. Then it put together and gave glucose, and that was supposed to be meant for energy purposes. The SGLT2 receptors are the only receptors which handle glucose in the kidney, whereas there are multiple transport mechanisms for sodium in the kidney. So while there is a downstream gradient for sodium, there is an uphill movement for the glucose. And the only way the glucose can get reabsorbed is to piggyback on the sodium and come into the intracellular compartment, and then through the basolateral membrane come into the interstitial space. The SGLT2 inhibitors are low capacitance, low affinity, and a high capacitance system, whereas the SGLT1 has got a high affinity and a low capacitance system. For every sort of for every sodium that gets reabsorbed from the SGLT2, there is 1:1 relationship between sodium and glucose, whereas when it comes to the SGLT1, there is a 2 sodium to 1 glucose reabsorption. And on the right of the slide, you can see the SGLT2 and the SGLT1 selectivity with the maximum specificity for the empagliflozin, and then followed by the other gliflozin that is present. And that's why perhaps we've had a majority of the data come from the empagliflozin studies. And then, of course, we've had the canagliflozin, the dapagliflozin, the ertagliflozin, which have really shown us. Well, this was a very good study, and they looked at the time course excretion of the PET tracers into the urinary bladder. And they were trying to show the functionality of the SGLT2 and the GLUT receptors. And what they did was that the MET4-FDG are really specific for the SGLT2 inhibitors. And if you look at the 2-FDG, they are substrates for the GLUT2. And after you give the IV injection of 2-FDG, the tracer is rapidly excreted into the urinary bladder of the wild-type mice at a rate of the filtered glucose consistent with the FDG of the substrate. Now, if you give an IV injection of MET4-FDG consistent with the tracer of SGLT, this more or less of total reabsorption that occurs in the wild type mice. Now, if you knock off the GLUT2 by a GLUT2 knockout mice, you find that most of the FDG that is there gets excreted because at the rate of 2 FDG. And if you knock out the SGLT1 and the SGLT2, the excretion is less. The more reabsorption occurs with the SGLT2 knockout mice as compared to the SGLT1 knockout mice. So these are the earliest receptor studies that were present. And if you give an IV injection of MET4-FDG, and if you block it off with the dapagliflozin, you find that most of the glucose that handling that happens, or the glucose excretion that happens, does not get reabsorbed, and it gets unexcreted into the urinary bladder. Now, the SGLT2 density is maximum in the kidney, and it is more located in the renal cortex. And these were the earlier studies that have been presented. And this is the mechanical model of the SGLT2 receptor that has been shown, where you've got an outer gate and the inner gate, and there is an internalization first of the sodium, and then it piggybacks onto the glucose also. So the outer gate closes and the inner gate opens, and you have glucose and the sodium reabsorption that tends to occur. Now, this is the homology model of the SGLT2 and the SGLT1 that has been shown in the three-dimensional structure. And if you look at all the physiology, it generally have a dietary intake of more than glucose input of more than 280 grams per day, of which the dietary source is more than 180 grams, and the glucose production is roughly about 100 grams per day through gluconeogenesis and glycogenolysis. The glucose uptake that happens is more than 250 grams per day. Brain takes in about 125 grams, and the rest of the body about 125 grams. The average blood glucose is about 150 grams. Kidney filters all the circulating glucose. And normally in a day, glucose filtered is about 270 grams. Most of this is, of course, reabsorbed. Now, this is how the postulation of the absorption, the excretion and reabsorption process tends to happen, and that's how the glucose homeostasis is maintained. What happens in diabetes is basically there's a shift to the right where there's less excretion of the glucose and there is more reabsorption that tends to happen. And that's what results in hyperglycemia. So the moment you give SGLT2 inhibitors, there's a leftward shift with more excretion of the glucose happening. And that's what also results in calorie loss and weight loss. Now, there has been a lot of studies, and these are the stories that have been there, which have translated into CV outcome trials, as well as renal outcome trials, which have sort of, become the order of the day. And that's where we are in terms of treatment today of all the various cardiological disorders, renal disorders, as well as the treatment of hyperglycemia. And this is the physiological effect of SGLT2 inhibitors on the kidney, the liver, the heart, and the adipose tissue. So while there is a calorie restriction mimicry, the A1C reduces, and coupled with that, the fasting and the postprandial glucose also tends to reduce. The volume offload that tends to occur causes the blood pressure to drop, and there is a hemoconcentration, and there is a metabolic efficiency that happens from a substrate switch. And we know now that the ketones are a preferred fuel, and that's how the benefits in the heart failure studies have been shown. There have been major risks and benefits, and you can see over here, while the benefits have been in terms of A1C reduction, weight loss, blood pressure reduction, MACE events, which have reduced, the reduction of heart failure, hospitalization, and renal protection, there are a small segment of people who do tend to get problems with genitourinary infections, decay, amputations, fractures, volume depletions, and AKI. Now, these were the modeling that happens, and this is what really causes the cardiovascular protection. So while it reduces the left ventricular hypertrophy, the inflammatory pathways, the extracellular matrix remodeling, the impaired cardiac metabolism, and the cardiomyocyte apoptosis, the SGLT2s have shown to reverse all these pathophysiological processes. And whereas the renal effects stem from the fact that in diabetes, you get dilated afferent arterioles, which causes increase in the intraglomerular pressure and injury, which results in increased proteinuria. And what really SGLT2 inhibitors do is it constricts the afferent arteriole, reduces the intraglomerular pressure, and concomitant reduces the proteinuria. And this is the entire hemodynamic cascade that tends to happen, which preserves the glomerular, the tubular, and the endothelial function, reduces the risk and severity of acute kidney injury, and improves the renal outcomes in large CVOTs. We know that the interstitial fluid volume is preferably reduced, and it does not affect much the intravascular volume, and this is a benefit of using the SGLT2 inhibitors. And this is the consequences on the glucose, the salts, the water excretion, and the impact on the kidney, liver, and heart. For want of time, I would not like to go into the details of this, but this is how the entire sequencing of glucosuria, the effect on the heart, the effect on the kidney, and the liver takes place, which ultimately results in better outcomes for patients. Not only that, there is a sort of a reshift of the insulin-glucagon ratio that tends to happen, which benefits in terms of the adiposity, although there is an increase in the glucagon-driven problems or physiological mechanisms, but the glucose uptake and the handling is tend to override that, and you get an increase in the lipolysis, and that sort of causes a increase in the non-esterified fatty acid uptake, decrease in the inflammation, and increase in the browning effects. So this is some of the liver fat results that have been come forth from the EMPA-REG, and what they have shown is the aminotransferases in individuals with type 2 in a pattern potentially consistent with reductions in liver fat, and additional studies would be required for use in NAFLD and NASH. We have now, with the introduction of SGLT2 inhibitors, all the guidelines have been rewritten, and what we were conventionally talking about, lifestyle modification followed by metformin, and then addition of a second agent, we now understand that although we still keep the lifestyle modification and metformin as a primary way of treating diabetes, but now we look at comorbidities, and if you have an ASCVD predominance or a heart failure or CKD predominance, a choice becomes obviously either an SGLT2 inhibitor or GLP analog. Clearly, if there is patients who are predisposed for getting hypoglycemia or an increased weight, SGLT2 inhibitors have become the order of the day, and more people are using this molecule. And this has been the ADA and the ACE guidelines. And now we have got, of course, a lot of CVOT trials, which I'm not going to go into details, but the whole point that the story really relates is that although earlier drugs were really evaluated for basically the efficacy after the rosiglitazone story, now the FDA has mandated that does a drug become CV safe and does it have a non-inferiority placebo? But after the leader trial and the EMPA-REG, we now looked at the drugs more in terms of CV protection, and can it be superior to placebo? And over a period of time, we have had all this published SGLT2 CV and renal outcome trials, the EMPA-REG, the CANVAS, the Declaratimi 58, the CREDENCE, the heart failure, and then they have shown the outcomes, beneficial outcomes in all the subsets of patients who have various events in terms of either MACE events or hospitalization for heart failures or renal composite endpoints, progression of the kidney disease, or reversal of the proteinuria, or time taken to dialysis or transplant. And these are all the different trials the Emperor reduced, the DAPA-HF, and they have looked at in patients with diabetes as well as non-diabetes. And clearly now we have great data to show that the drug is equally efficacious in patients with diabetes or non-diabetic, and now perhaps has become the order of the day to use in patients with heart failure, irrespective whether the patient has got a diabetes or non-diabetes. And these are some of the mechanistic actions. But what is important is there are potential direct effects of SGLT2 and indirect effects of SGLT2, which benefits patients in heart failure. And these are all the mechanisms that have been responsible for benefit in the heart failure. So if you have today patients who require MACE protection, both are good. But patients who have got an atherosclerotic cardiovascular disease without heart failure, probably GLP-1 has a better role to play. Patients who have got an ASCVD heart failure, or you're looking at concomitant renal disease, perhaps then the SGLT2 inhibitors are the way to go. And these are some of the kidney trials that are in progress. Some have already been completed, some are in progress, and they have looked at concomitant cardiovascular and renal effects, and all have been shown to be in positive. And some of them trials have been stopped prematurely because of benefits that have been seen in all these trials. So you've got the deep DAPA CKD, you've got the Emperor reduced, you've got the Emperor preserved, and now you've got also the trials that are coming in patients with heart failure with preserved ejection fraction, that is the Emperor preserved and the delivered trials, and we want to see those results. So although we have got good results in the reduced ejection fraction, I'm sure we will interestingly look at all the trials which are going to be seen with the preserved ejection fraction. So if I have to sum up, and I have to look at three parameters: the lowering of the A1C, the safety where hypoglycemia prevention is concerned, and the CVD protection, clearly you find that across the board, you've got efficacy which is good in most of all the oral hypoglycemic agents. But when it comes to CV protection, you find that the SGLT2 class and the GLP-1 are sort of preferred options. And this probably has now become the way we all treat patients with diabetes. So if you're looking at low budgets, you're probably looking at sulfonylurea and pioglitazone. If you're looking at patients who have got obesity, then GLP-1 and SGLT2 inhibitors are the choice of agents. Patients who've got an ASCVD heart failure, the first choice is, of course, SGLT2 inhibitors, followed by the GLP-1 RA. And patients who've got an ASCVD without heart failure, then perhaps it's GLP-1 RA the preferred over the SGLT2. And this is the pumps and the pipe story, where pumps failure would probably warrant an SGLT2 inhibitors, and the pipes which have got occluded would require to have a GLP-1 RA. And patients who've got CKD with a GFR of less than 45, so although our initial indication to use was GFR more than 45, clearly the new intervention trials have shown that even at low GFRs, they are equally efficacious in terms of programs.
Okay.
So I'll end up now, and thank you very much for this opportunity. And what I would really like to say, the story of SGLT2 really continues. We are seeing more and more data come every single day. And perhaps the future holds a lot of promise, and maybe our way of treating patients of diabetes or non-diabetic population, where you find that none of these problems occur in singularity, and you've got also patients who've got cardiovascular problems, renal problems, and maybe use of SGLT2 inhibitors are going to change outcomes and make them in a better space for prolonged life. Thank you very much for your patient listening.
comes with what is known as low sodium salt, 30% less than the common salt. It's called Light, L-I-L-Y-T-E. I don't know the name, the company, but that's what is coming out. So 30% sodium coming down is a pretty good effect on the common.
Yes, no doubt. That is what is the date is that we have to reduce 30% sodium by 2025. But I don't think each one of us will agree that there is no attempt to bring it down. 2025 will be yet another, like we used to study in our SPM days, health for all by 2000. So that slogan has died out. I think the same way this salt in 30% less will also meet the same fate. It will die out by 2025. But I'll say salt is a reality, and we by nature are more salt consuming nation. We pickles, the preservatives, and in fact, when I was going through the historical perspective, the word salary comes from salt, which was given to Roman soldiers to buy salt to preserve the food. Salary was given, salarium was money given to them to buy salt so that you can preserve food. Called Salzburg in Austria.
Yes.
Market outside, because that used to be the European center of salt trade, and over a period of time it was misnomered as Salzburg. It is Saltburg. So there are many stories, and more you read, more you feel pleasure about it, because you understand how our forefathers have worked hard to bring these issues which look so simple to understand and so pleasant to talk to and understand.
Dr. Agarwal, I think it was a wonderful talk, Dr. Rajiv.
No, I enjoyed your talk. It is not a mutual praise, but I enjoyed your talk, and you have to pass on the credit you gave me to Dr. Sondhi, because together he thought, I asked him what we should do next. He said, he introduced me the book, which I introduced you to. And Dr. Sondhi should be given that credit that he introduced me that book. Yeah, it is his courtesy.
I think we're all going to read that book very much.
Yeah. No, I would, on a lighter note, Dr. Rajiv, would you recommend that we should lick our patients' sweat to decide whether he is to be given a diuretic or an ACE inhibitor? Wonderful. I think that was a very nice story.
I personally, in an older patient, use lots of chlorthalidone.
Yeah, we all do.
Plus, and both the NICE guidelines also suggest that if you are 50 years plus, ACE inhibitor, ARB, since your renin-angiotensin axis goes down, they are less helpful. So I use lot of chlorthalidone as a monotherapy in stage 1 hypertension. I'll say I am happy about it.
Let me ask you a question.
This question Dr. Khalila was asking about, the usage of statins in 80 plus individuals. I would like to have the views of the House on that. And also, a lot of times people will ask me that, we write 80 milligrams of statin, high dose statin in post-PCI patients or a post-ACS even without an intervention. Should we continue with 80 milligram indefinitely, or do you have a time frame of which you'd like to reduce the dose and bring it down to about half? I mean, in your clinical practice, there's no recommendation as such, but like to have the views of the senior people here. Dr. Khalila Sahab, if you want to sort of rise us on that.
Well, I think looking at the body weight of the Indian subcontinent, the dose of 80 milligrams is pretty high. I would suggest that acute myocardial infarction or preceding or following the PTC, one could do that for some period of time, then scale it down. But I think some people write very high doses for long period of time. I'm not too sure whether there are control studies available or not.
Yeah,
to justify very high doses with. Right.
Can I ask you a question? I mean, you've got all the eminent cardiologists and internists over here. How much of SGLT2 inhibitors are you using, and which has influenced, as your primary prescription, and how has it changed your outcomes?
Most of us are very addicted to SGLT2 because it is cost effective and very quick to give you immediate dividends. So cardiologists are, I will say, we have more apart and practicing physicians, because cardiac failure patients come to us. They don't go to endocrinologists, and the endocrinologists don't have the moral or the cardiac failure. Let me say very honestly, they must be scared. So we have the immense opportunity, and without fail, I can speak on behalf of Dr. Khalilullah and Dr. Narayan that cardiologists are using a lot of SGLT2 inhibitor. There is a little bit of inhibition in GLP injectable, and I will say side effects are more. There's a lot of 30% people will complain of vomiting limits, and then every injection in this country is taken by patient as insulin. Whatever you convince them, they don't want. Injection is a phobia. So cardiology community is very, very proactive and very enthusiastic about it. There is no doubt about it. And I always say we have the patients, and it is our mandate to use them. There is no ambiguity in the literature.
I totally agree with you, Dr. Rajiv. No practitioner worth his name can practice diabetes treatment without using SGLT2 inhibitor. It's almost as good as that. So we are very eagerly looking forward to the data which we'll get in preserved ejection fraction, because preserved ejection fraction is again quite common, which we are missing. And there is not much treatment available. So I'm very eagerly looking forward to the data.
I agree.
The data,
so, Dr. Agarwal, question is often asked in the light of what the recent trials have shown. What is your usage of SGLT2 inhibitors in patients who are non-diabetics but heart failure?
Yeah, so I think if you look at the HF study, they have shown benefits in both the classes, and almost if you look at all the primary and the secondary endpoints, they've all shown benefits when it comes to first onset of heart failure or rehospitalization from heart failure or cardiovascular mortalities. All have shown that even in low ejection fraction.
That we know. That is what I was asking Dr. Rajiv, because he emphasized that as cardiologists, we are into using a lot of SGLT2 inhibitors. So my usage would be almost 50-60% of my patients would be in SGLT2 inhibitors if they are diabetics with heart failure. Now, if you are a non-diabetic with heart failure, what is your usage?
That is what I want to ask. The same data holds true what is in the diabetic population.
Data I know, data we know. The practice.
Practice, I'd probably, less than the cardiac, but we do use even in non-diabetic population. SGLT2 inhibitors, and they're fairly safe. I mean, you don't get hypoglycemia with the drug. That's a major thing that you really.
Yeah, I agree.
Yeah.
So, in your practice, are you using SGLT2 inhibitors in heart failure without diabetes?
I am using.
It's slowly catching up. But I think mainly diabetic patients.
So do you think that ARNIs and SGLT2s have completely modified the treatment of heart failure, and now I think they have become the choice of drugs? ARNI and SGLT2 inhibitors, followed by, of course, other agents that you tend to use. So, what would you say that how much ARNI percentage you use?
Dr. Khalilullah's question whether he needs aspirin or statin if he is in primary prevention, then beyond 75 years of age, yes, he has to continue. It is as simple as that.
Very good.
And I know he is in primary prevention.
As yet, Dr. Sanjay Agarwal, on the lighter side of the whole thing, I spent a year in Pune in 1971. Where I was their chief of cardiology in Own Chest Hospital. On a salary of 50 rupees a month.
Wow, that's really a story.
After my clear from all distributed medical sciences, the first opportunity I got was to go to Pune to set up a department of cardiology, started cath lab, I started closed heart surgery, open heart surgery. I spent a year there. And still a friend of mine by the name Madhav Kade, who is a pulmonologist. I think he visits Ruby Hall from time to time.
Yes, he is still around. He's still
yes,
around.
yes, yes.
He's still
and
around.
it's very different. I travel around every day and come back, you know. I should stay
those who have not worked under Dr. Khalilullah should not be mistaken. He is such an easy person with his students. He taught us cardiology with all the danda, and we are all grateful to him for doing that. You see, it was fear. I know his driver, and I'll ask him, boss. He used to say, boss is not coming. Your heart rate goes down by 10 beats per minute. so
I was like, I had an eagle's eye, but I just heart, you know. So that's how I behaved with my students. They're very dear to me.
Yes, no doubt about it.
I adore those days when I was with all this.
Dr. Sanjay, I must tell you, there was no festival when the will come from chief's house.
Oh, okay.
It was a written rule. It was a written rule. And I have learned another very big thing from him. If I am knocking his door 8 a.m. for his professional job as a registrar, if he is sitting on a breakfast table, I was never asked to stay in the balcony. I was never asked to sit in the drawing room. I was called at the breakfast table. And he will say, "Ye ladka non-veg nahi khata hai, isko zara dusra." So that is the kind of magnanimity we learned from him, that students are to be treated. He never called Rajiv. He will always say in public, Dr. Sahab. That is another beauty. He will never be accompanied by an army of registrar. Being a director, professor, and being director of GV Pant, there must be 20 people following him. But no, he will walk alone in the corridors of GV Pant Hospital. Always, always, always. So he is a great icon in cardiology, and people who know me, there's a lot of reflection in my social and professional life.
I think as students, we used to always, read about him, and there were anecdotes which are mentioned about him. Yes. So although I never came in personal contact, but he still remained a legend for us, even when was
too young. You are too young, and let me say, unfortunate that you couldn't see him working. He'll work 16 hours a day. He is such a difficult boss. He will ask you. I was a registrar in his ward. Rajiv, visit me when you finish your job, because he's sitting till 9 p.m. in the hospital. So we have to go back to the hospital, have a nap, come back, and show to the boss that I'm the last person to go as a registrar.
These are real stories.
And a great trainer.
It was enjoyable era, I lived family together. It's all my kid and kid, let me tell you. I am very proud of each one of them. Very proud of them.
We are proud that we are privileged to have you as our teacher, mentor, and father. I think, Amit, with that note, and Dr. Adip Mitra is another icon in our. He will come on Sundays and you will curse him. Why he has come on Sunday, and he will come at 9 kind of thing. If he comes on night rounds, 8 p.m. may leave at 12. So these are the people who have shaped medicine. And unfortunately, these leaders are lost to corporate world. Newer generation doesn't have these kind of role models who have trained students so hard like their own children. I'll say that.
Dr. Rajiv, I'll end by a small quote. The treatment of every ill is salt water, sweat, tears, or the sea. Thank you very much.
Thank you.
You can close.
Thank you, all the eminent national experts, and it's been a great honor to have you all today on this virtual platform. On behalf of Intas Pharmaceuticals Limited, I must thank all the delegates who have joined in from various parts of the country. We had more than 1,000 delegates who have done this, who have attended this webinar today. And we are really honored to have legends like Professor Khalilullah. I used to meet him as a medical representative in Delhi when he had his clinic in Daryaganj, and I used to go there. And now I'm in Ahmedabad. I would thank Professor Narayan, Professor Adip Mitra, Dr. Sondhi, and Dr. Sanjay Agarwal for their presence today on this podium. And at the last but not the least, I would thank Dr. Rajiv Agarwal for conceptualizing the whole thing. In fact, he has been the guiding light in this program. It's a unique program which he has guided us for today. Stories in medicine. In fact, I have already got many feedbacks, which are there on the chat box. I will share with you.
Let me say, was having a wine in a dinner and something like this, and that's how the great idea came.
Okay. So I think it's been a pleasure to have you all here, and I must thank each one of you for wonderful presentations, and this has been a great evening spent on this platform. Thank you very much once again, and good night to all of you.
Thank you. And good night. Good night.